Section 3.4 is about finding the distance between 2 points. In problem number 1, let's write down the coordinates of point A. Point A is at 5, 5. Number 2, write down the coordinates of point B. That is 5, 1. How can you use the coordinates for points A and B to determine the length of the line segment? So all I really need to do is look at these y coordinates to see the distance between them. So I'm going to find the difference between the y coordinates. In number 4, we'll actually find that length. I'm going to take the larger number minus the smaller number. So 5 minus 1, and I'll get 4. The distance between the points is 4 units. In number 5, let's write down the ordered pair for point C. It is at -5, +2. Point D is at 6, 2. I can see how far apart they are by looking at the x coordinates. I'm going to answer question 7 and say that if I find the difference between the x coordinates, then I can find the between the points. Number 8, I'm going to actually find that length. So take the bigger number, which is +6, and subtract the smaller number, which is -5. 6 minus -5 is the same as 6 plus +5. That equals 11. How can you tell when you can determine the distance between 2 points by subtracting the x coordinates? I can subtract the x coordinates when the y coordinates are equal. How can you tell when you can determine the distance between 2 points by subtracting the y coordinates? That is when the x coordinates are equal. Let's practice doing this. For number 11, I'm given the ordered pairs, -2, 1 and -2, 8. Did you notice that they both have an x coordinate of -2? So that means I'm just going to look at the y coordinates. I'll take the bigger one minus the smaller one. 8 minus 1. So that gets me 7. Number 12, the y coordinates are the same. So that means I'm going to subtract the x coordinates. Take the bigger one, 5, and subtract the smaller one, -8. That means I'm going to have 5 minus -8, which is the same as 5 plus +8, which is 13. Number 13, did you notice the y coordinates are the same? So that means I'm going to subtract the x coordinates. 21 minus 18 is 3. Okay, pause the video and try number 14, and then start the video up to see the answer. The x coordinates are the same in 14, so I'm going to subtract the y coordinates. 12 minus -5. That is 12 plus +5, which is 17. Instead of just looking at horizontal or vertical, we need to also look when the points are at a diagonal to one another. So we're going to extend our thinking a little bit. The graph below represents the sidewalks in a nearby neighborhood. Each unit on the graph represents one step. Suppose you want to walk from A to B. Using sidewalks in order to stay off of the grass, you start at A and walk to C. From C, you walk to B. What is the measure of angle ACB? Well, angle ACB is a 90-degree angle. So we know we're turning the corner there at C. How many steps are in the walk from A to C? There are 3 steps. How many steps are in the walk from C to B? There are 4. 3 on this side and 4 on this side. If you go and walk all the way to B, following that path, you would walk 3 plus 4, or 7 steps. Cross this out. You decide to take a shortcut and walk directly from point A to point B in a diagonal path through the grass. Recalling the answers from the previous page, we're going to draw in segments AC, so that would be the horizontal segment, and C was here. Draw in segment BC, right there. What type of triangle is triangle ABC? It is a right triangle. AB is referred to as the hypotenuse of the triangle. Is it appropriate for the Pythagorean theorem to be applied to find the length of AB? Yes, That would be appropriate because we have a right triangle. We are going to find the length of AB. Now we know 3 is on AC and 4 is on BC. And we learned about a right triangle with legs of 3 and 4. The hypotenuse then is 5. So the length of AB is 5. Which path was shorter? If you walk from A to B by staying on the sidewalk, or when you walk directly from A to B through the grass? I hope you said the second one. If we do look at points on the diagonal, maybe if we observe their horizontal and vertical distance first, then we can use Pythagorean theorem to find the actual distance. If you get points S and T, find the horizontal only distance. That means the x coordinates. We're going to look at the x coordinates. So look at the 2 and look at the 14. Let's subtract. The bigger number minus the smaller number gives me 12. So the horizontal distance is 12. And then observe the y coordinates. So look at 4 and 20. Subtract 20 minus 4 and you get 16. Just for a moment, let's remember what we did on the previous page. The horizontal distance this time though is 12 and the vertical distance is 16. To go from S to T, we have this right triangle helping with the path. We could use Pythagorean theorem. Now I recognize the 12 and the 16 as being part of a triples family. So I'm going to think of 12 as 4 times 3. I'll think of 16 as 4 times 4. So just look at this factor, not the 4, but the second number. 3, 4, 5. This is a 3, 4, 5 triangle, but each of the sides gets multiplied by 4. So don't forget to multiply your side by 4. The answer to this one is 20. The distance from S to T is 20. Okay, let's go to the next example. Given the points C and D, compute the distance. So I'm going to repeat the same method. I'm going to find the difference between 18 and 6. So 18 minus 6 is 12. And then the difference between the y coordinates, 12 minus 7 is 5. If you need to, you can get a right triangle set up, and the horizontal distance is 12, the vertical distance is 5. Does this look like a triples family? If it does not, we would use Pythagorean theorem. But I do think we have a triple family here. This is a 5, 12, 13 triangle. So the hypotenuse is 13. Number 16, the horizontal distance is going to be found by taking -2 minus -5. So what is -2 plus 5? That would be +3. For a triangle, you have a horizontal distance of +3. Now let's go from -3 to +1. So I'm going to try 1 minus -3, which is 1 plus +3, or 4. So our vertical distance is 4. And I know you know the hypotenuse of this triangle. That would be a hypotenuse of 5. We're going to practice this method finding perimeter of different shapes. So the perimeter of the first shape is a rectangle. I'm going to count the units. There are 6 units on this side, which means there's 6 units on the top. There are 4 units on this side, so there are 4 units on that side. So I'm going to add up the sides. 4 plus 4 plus 6 plus 6, and I'm getting 20. Number 2, the bottom of the triangle is 4 units long, and the left side is 5 units long. I would love to say this is a 3, 4, 5 triangle, but it is not, because the 5 is not on the hypotenuse. So that means I have to find the hypotenuse. We oftentimes call that C, so my setup would read 4 squared plus 5 squared equals C squared. And you can use your calculator. That is 41 equals C squared. So C is the square root of 41. Now that's not the same kind of number as 5 and 4. That's irrational. So I can add the 4 and the 5 together, but I cannot add the root 41 to that and get an exact answer. So this will end up being 9 plus root 41 as the perimeter of that triangle. Number 3, the bottom of the triangle has length 6. In order to get the other sides, they're on a slant. So I'm going to do this. I'm going to think of a right triangle inside of this, and the bottom of the right triangle has a 3, and the height of the right triangle has a 4. So that means the hypotenuse is 5. The same is happening on the left side. So I just need to do 5 plus 5 plus 6, which is 16. Number 4, I can easily count 4 units on the left and 4 units on the right, but the slanty side I'm going to have to look at a right triangle. So down below, you could draw the right triangle outside of the shape. The right triangle would have, the side on the right would be 1, so the leg of 1, and then another leg of 4. So in order to get this side, the slant side, I'm going to set up Pythagorean theorem. Do 1 squared plus 4 squared equals c squared. So the 1 squared plus 4 squared is 17. That means c is the square root of 17. So if this is the square root of 17, this is the same length up here. So that's the square root of 17. So I'm going to add the real numbers together, and then I'm going to add the irrational numbers together. I'll get 8 plus 2 root 17. Number 5, if I count the units at the bottom, there are 7, and at the top there are 2. And then I have to look at the slant side on the left. That has a base of 1 for the triangle inside and a height of 4. And we just did that triangle calculation in number 4. So this hypotenuse is the square root of 17, taking our work from number 4. This slant side belongs to a right triangle who has a base of 4 and a height of 4. So that would be 4 squared plus 4 squared equals c squared. Using my calculator, I'm getting 32 equals c squared. So c equals 4 root 2. So this side is 4 root 2. So the real numbers are 2 and 7. Then I'm going to add the irrational numbers, root 17 and 4 root 2. They cannot go together, so I'm going to have to write them apart. 9 plus root 17 plus 4 root 2. Sometimes we might ask you to turn that into a decimal. Number 6, the top has length 2 and the bottom has length 2. And then the slant sides are the hypotenuse of a right triangle with a leg of 1 and a leg of 2. That's 1 squared plus 2 squared equals c squared. 5 equals c squared. So c equals root 5. That means all of these are root 5 because they're all the same length. I have 2 plus 2 plus root 5 plus root 5 plus root 5 plus root 5. So that's 4 plus 4 root 5. The next page has our closure on it. So I would like you to pause the video and do these 4 problems, then turn the video back on and check your answers. We're going to check your answers. I'm noticing in number 1 that they do not have x coordinates the same or y coordinates the same. So I'm going to compute the horizontal distance. 8 minus 5 is 3. So that's like the horizontal side of the right triangle has a length of 3. Now check the vertical distance, the y coordinates. This would be 4 minus negative 2, which is the same as 4 plus positive 2, which is 6. So the other leg has length 6, and that means I'm going to have to use Pythagorean theorem because that is not a triple. So 3 squared plus 6 squared equals c squared. 45 equals c squared. So c equals 3 root 5. Number 2, the x coordinates are the same. I'm going to check the distance between the y coordinates. 9 minus 1 is 8. So that's the distance between the points. Number 3, the y coordinates are the same. So find the distance between the x coordinates. The distance is 6. Number 4, the x distance between these points is 2 minus negative 6, which is 2 plus positive 6, which is 8. The difference between the y coordinates is 2 minus negative 6, which is 2 plus positive 6, which is 8. The horizontal distance is 8, and the vertical distance is 8. So now I'm going to have to use Pythagorean theorem. 8 squared plus 8 squared equals c squared. That's 128 equals c squared. So c equals 8 root 2.